Good morning. MSc Physics previous. In previous videos, we have discussed differential amplifier, its DC and AC analysis, and constant current bias. Today we are going to discuss current mirror and level translator. So what is a current mirror? Current mirror is a circuit in which output current is equal to the input current. In other words, the output current is a mirror image of the input current. The current mirror is a special case of constant current bias and therefore it can be used to set up constant emitter currents in differential amplifier stages. The circuit diagram of current mirror is shown below. In this circuit, current IC3 is equal to current I2, where I2 is the input of this current mirror and IC3 is the output of this current mirror. IC3 is the collector current of transistor Q3. Current mirror circuits are most commonly used in integrated amplifiers because of its simplicity and ease of fabrication. In this circuit, transistors Q3 and Q4 are identical. Hence, their base emitter voltages must be same and also their base and collector currents must also be approximately equal. Hence, VBE3 is equal to VBE4 and IC3 is equal to IC4. Also, IB3 is equal to IB4. From the circuit, we can see that current I2 is equal to IC4 plus I. Further, current I is equal to IB3 plus IB4. Since the two transistors are identical, current IB3 must be equal to current IB4. Hence, current I is equal to 2 IB4. Therefore, current I2 is equal to IC4 plus 2 IB4. We can write equations for these currents. I2 is equal to IC4 plus I, where I is equal to 2 IB4. So, I2 is equal to IC4 plus 2 IB4. IB4 is equal to IB3 and IC4 is equal to IC3. So, we can write I2 is equal to IC3 plus 2 IB3. IB3 can be written as IC3 divided by beta DC. Therefore, I2 is equal to IC3 1 plus 2 by beta DC. We know that beta DC is generally very large. Therefore, 2 upon beta DC is very small and hence I2 can be written as I2 is equal to IC3. The current I2 can be obtained by writing the Kirchhoff's voltage equation for the base emitter loop of the transistor Q3, and I2 is obtained as VEE minus VBE3 divided by R2. So I2 depends on resistance R2 and R2 can be chosen to set a desired value of collector current. For satisfactory operation of the circuit, it is necessary that two transistors should be identical. Now we will discuss what is level translator. We know that differential amplifier is the basic building block of operational amplifier. There are many stages in operational amplifier. The first stage is dual input balanced output differential amplifier, and the second stage is dual input unbalanced output differential amplifier. This second stage is coupled directly to the first stage, and we know that in direct coupling there is no bypass and coupling capacitors. Because of this direct coupling, the DC level at the emitter rises from stages to stage. Hence, level translator circuit is needed to reduce this DC level to 0. Each amplifier stage produces AC amplification of the signal, but at the same time, the DC level is shifted due to the bias voltages. This increase in DC level tends to shift the operating point of transistors of the succeeding stages and therefore limits the output voltage swing and even distort the output signal. Therefore, level translator circuits are used to shift the output DC level to 0. Level translator circuits are also called as level shifters. So, level shifters are the circuits that shift the input voltage in order to compensate for DC offset voltages. Operation amplifiers have level shifters included in their design. There are a variety of level translator circuits. An emitter follower with a voltage divider is the simplest among them. The circuit diagram of this emitter follower circuit with voltage divider is shown here. The positive DC voltage at the base of this transistor can produce 0 volt at the junction of R1 and R2 with proper selection of these components. In this way, this circuit can produce 0 volt at the output with a positive DC voltage at the input. Better results can be obtained by using an emitter follower either with a diode constant current bias or a current mirror instead of the voltage divider. The circuit diagram of these two circuits are shown below. This is a circuit diagram of level translator where R2 has been replaced by a diode constant current bias. This provides better stability to the circuit. And this is the circuit diagram of a level translator where R2 has been replaced by a current mirror. We can also use a Zener constant current bias with emitter follower in forming a level translator. But a emitter follower current mirror level translator is mostly used in operation amplifiers. Thank you.